This video is a walkthrough of an exam-style question on the topic pre-implantation genetic diagnosis. Hayden and Kayla are planning to have a baby. However, they both have family members afflicted by cystic fibrosis, a genetic disorder that affects the body's lungs and digestive tract. Hayden's father and Kayla's grandmother both had the disease. This is shown in the pedigree below. For this exercise, the dominant allele is capital T and the recessive allele is lowercase t. This scenario is very similar to real-life examples. Aware of their family histories, Kayla and Hayden consult with their doctor before conceiving a baby. Their doctor informs them that cystic fibrosis is an autosomal recessive disease, meaning that they could carry a recessive allele for cystic fibrosis without having the disease. Assuming that individuals 2-2 and 2-3 in the pedigree are homozygous dominant, what are the respective probabilities that Hayden and Kayla are carriers for cystic fibrosis? Alright, so starting with Hayden, looking at the pedigree, we can see that his father is affected with cystic fibrosis, meaning his genotype is lowercase t, and from the question, we know that the mother's genotype is dominant. With this information, we can perform a monohybrid cross using this Punnett square, and the results show us that Hayden is in fact a carrier for cystic fibrosis. Now, looking at Kayla, we see that her grandmother is affected with cystic fibrosis, so we know that her genotype is homozygous recessive, which means at least one recessive allele must have been passed to Kayla's mother. Kayla's mother does not have cystic fibrosis, so we know that she is heterozygous. From the question, we know that the father is homozygous dominant, and with this we can perform another monohybrid cross, and the results show us that Kayla has a 50% chance of being a carrier. Moving on, once aware of her chance of being a carrier, Kayla decides that carrier testing is a good idea. The results of the test show that Kayla is indeed a carrier for cystic fibrosis. What is the probability of their child having cystic fibrosis if Kayla and Hayden conceive naturally? What is the probability of their child being a carrier and homozygous dominant? So since we know Kayla and Hayden are carriers, their genotypes are capital T, lowercase t, or heterozygous. With this information, we can perform another monohybrid cross, resulting in the 3 different genotypes shown. Now, thinking back to the question, we have to consider the different genotypes in the Punnett square. As you can see, there's a 25% chance of homozygous recessive. This means there's a 25% chance the child will have cystic fibrosis. There's a 50% chance of being heterozygous, meaning there's a 50% chance the child is a carrier, and that leaves 25% chance that the child will be homozygous dominant. Now, why would their child being homozygous dominant be more ideal than the child being a carrier? Well, if you think about it, the benefit of being homozygous dominant is the inability to pass the cystic fibrosis causing recessive allele to future generations. If Kayla and Hayden's child is a carrier, then they have to consider the possibility of having cystic fibrosis affected children themselves. Although the knowledge that their child could have cystic fibrosis was concerning to Kayla and Hayden, their doctor informed them about the process of pre-implantation genetic diagnosis during in vitro fertilization. Now, if 5 of Kayla's ova are fertilized with Hayden's sperm through in vitro fertilization, what is the probability that at least one embryo is homozygous dominant? What is the probability that all embryos will be homozygous recessive? So let's start with the first part of this question. What is the probability that at least one embryo is homozygous dominant? Now, n equals 5. That means that there are 5 embryos in question. And from the monohybrid crosses shown earlier, we know that there is a 25% chance of homozygous dominant if Kayla and Hayden's gametes combine. This leaves a 75% chance of other genotypes. Now to solve for the actual probability, we will use an equation called binomial probability shown here. The values P and Q in the equation are the probabilities that we discussed a moment ago, the 25% and 75%. These values will be shown as 0.25 and 0.75. Now, if we just went ahead and solved for the probability that at least one of the 5 embryos are homozygous dominant, we would have to run the binomial probability equation a total of 5 times. The first time for if exactly one embryo was homozygous dominant, then if exactly 2 embryos were homozygous dominant, and so on. We would then add those probabilities to find the probability we're looking for. Instead, we will do 1 minus the probability that none of the embryos are homozygous dominant. This will give us the same answer, and it is much simpler. Okay, now we plug in our values for 1 minus the probability that none of the embryos are homozygous dominant, and we get a value of 0.763. This means that there is a 76.3% chance that at least one embryo of the 5 is homozygous dominant. Now moving on to the next part of the question, what is the probability that all embryos will be homozygous recessive? Again, we start with what we know. We know that there are 5 embryos in question, and again from the monohybrid crosses shown before, there is a 25% chance of homozygous recessive if Kayla and Hayden's gametes combine. That leaves a 75% chance of other genotypes. Again, we will use the binomial probability equation, and we are looking for the probability that 5 of the 5 embryos are homozygous recessive. Little t, little t. After plugging in these values, we see that there is about a 0.1% chance that all of the embryos are going to be homozygous recessive. On to the last question. Based on your answers before, is PGD and IVF a good idea for Kayla and Hayden? For this question, we have to consider their chances of having a healthy child with and without the IVF and PGD. So PGD and IVF is a good idea for Kayla and Hayden because it increases their chances of having a healthy homozygous dominant child from 25% to 76.3% in this scenario. This is of course assuming that the pregnancy is successful. The important takeaways of this exercise are as follows. You can be a carrier for a disease that you are not affected by. 2 parents who are carriers for a recessive disorder have a 25% chance of having a child with that disorder if they conceive naturally. And finally, PGD coupled with IVF greatly increases the chance of having healthy children.